Mann. I'm Chairman, Co-founder and CTO of Bennamann, and today I'm going to talk a little bit about how we're going to use biomethane energy in the future in energy hubs. And for biomethane now, as you'll see, primarily we're going to be starting off with fugitive methane, which I'll explain. The company was founded in 2011, primarily to take my house off grid, and I looked at using solar, wind, and where I am there's no wind, and right at the bottom of the valley there's not a lot of solar and ground source heat pumps, and none of them really were going to be able to take my house off grid. They'd help with the energy. And then I was in Florida on a business trip, and there was a little piece about not leaving your grass cuttings in your garage when you go away for the weekend, because the heat from the air conditioning units would cause the lawn clippings to break down and form methane and hydrogen. And if you came home and turned the light on, you'd be lucky enough you might blow the house up. And at that point I thought, well, this is a lot of energy in grass, so how much is there? So I started doing a bit of research. I'm an applied physicist by background, and found out that actually there's a lot of energy in grass if you convert it into methane. And in the 1970s in China, there were over 30 million community-based anaerobic digesters that primarily digested human excrement, food waste, animal waste, and used it to cook because they had a problem with people cutting down trees for cooking. And we've taken that further forward now, and we were fortunate enough to find a farm just outside Truro that's got a sealed slurry lagoon. And we found that they were actually producing 6 times more energy through the lagoons, methane that was produced, than the farm needed. So we're actually demonstrating, as part of a European Regional Development Fund project, energy independent farming, to the point where actually we can now even replace the fuel of the tractors you're seeing. So we're a Cornish company. We've got actually over 30 staff now. We've taken 4 more people on yesterday in the engineering, scientific and commercial teams. And these have mostly been recruited locally, and we expect to double our workforce over the next 36 months as we grow. And we've got a really novel approach because we are able to make the methane anywhere without reliance on grid connection or gas grid connection. And this means that being local, we need people to go out and service the equipment and collect grass and slurry lagoon, which means it creates a lot of jobs in the rural economy. We're actually able to make the fuel cheaper than fossil fuels can be imported. And this then provides a potential solution for fuel poverty, which is a really important driver for us. Also, Cornwall gets export income through delivering energy. Cornwall spends about £1 billion a year on importing energy. But basically, our hub, we make everything is pretty much made in-house using our own guys. And we also have our development farm near Truro, Chinoeth, which means new house or new home in Cornish, interestingly, which is ironic when you consider what we're doing. And we're just building a custom manufacturing facility at Chinoeth now. We've had incredible support from Cornwall Council and Cormac, a lot of other local Cornish organisations, including TEVI, Dutch College, National Trust, Cornwall Wildlife Trust, the Environment Agency and University of Exeter, and others. I'm sorry if I've missed you off the list. And in March this year, Case New Holland Industries, which is a very large company that own New Holland, Case Tractors and Iveco, acquired a minority stake in us to help them with their methane projects. As you'll see in a minute, they're releasing a methane tractor this year. And in partnership with CNH, we're now rolling out product prototypes across the fugitive and biomethane value chain. And being a global company, it gives us global reach into huge manufacturing facilities as we expand. Primarily, the Bennamann cycle is all about closing the loop. So it's a circular cycle where grass captures sunlight, the grass is eaten by animals, their waste goes into slurry, which is captured in a lagoon, which we cover. And for the biogas, we process it, take out the biomethane or fugitive methane. Importantly, we can then store it either as compressed gas or liquid methane, and we can then deliver it to our customers on the road. And this is unique because it means that we really don't need access to the grid. Now, if you look at the methane potential of sustainably managed grassland, for example, 1 hectare, that's 100 metres by 100 metres, will give 20 tonnes of dry matter grown sustainably. And about 1 kilo of dry matter gives you 230 kilograms of methane. So the potential yield per hectare of grassland, and I'll talk a little bit about it later, is roughly equal to 7,500 litres of petrol per hectare per year. And actually, we're finding we can get better than that. And I'll talk a little bit about that later. Now, what people don't realise about methane is that it's actually responsible for 42% of the global climate change over the next 20 years. And 2/3 of that methane is in the atmosphere is produced by man. And about 1/4 of that is down to agriculture manure. So we think we can hit about 1/6 of the total amount of methane if we just clean up our act and capture the fugitive methane from lagoons. And interestingly there, we've got NOx as responsible for 3 points. And these are the numbers from the IPCC 5th assessment report. So these are pretty well established now. People tend to talk about the 100-year time frame, but we're interested about what's going to happen in the next 20 years. And methane is responsible for over 42%. And then you've got the fluorinated gases. So those fugitive emissions, those 3 gases are responsible for nearly as much as carbon dioxide. And for those that don't know, carbon dioxide is in the atmosphere for thousands of years, whereas methane is in the atmosphere for around about 12.4 years, which means that if we make changes now, we will see effects within 20 years. What this means is if we capture a kilo of methane that would, under business as usual, get into the atmosphere, that's the equivalent to removing 86 kilos of CO2 from the atmosphere, which is nearly a factor of 100. And the unique thing about methane is it's actually a global warming gas, but it can power its own capture and removal because it's also a fuel. And there's lots of energy still left over. So it is the best biofuel. Fugitive methane is by far the best biofuel because it's not carbon zero. It actually offers an 86-fold global warming potential benefit over zero carbon fuels, which means there's a carbon footprint of -86. So we've actually got an opportunity here. If we capture methane within the next 10 to 20 years, there's a potential for stalling the early onset of global warming. And some of the main political leaders, some of them in Cornwall this week, certainly Boris Johnson and the President, Mr. Biden, have been announcing how it's really important that we start to tackle the fugitive methane, in particular from the oil and gas industry. They need to sort themselves out. So just by cleaning up our acts, we can actually start to affect the climate directly in a very short period of time. What does it look like? Well, this is a little video from a very local slurry lagoon. It's been there 20 years, and this is in the winter, so the production at the moment at this point in time is very little. That in the middle of the screen is a methane release. One on the right has just gone off. Each of those is about 50 pence worth of methane. It's probably about half a cubic metre of biogas. I think you'll see a particularly large one down on the bottom left there. And I can tell you that smells from about 5 miles away. You can smell that. So not only are we sorting out the problem of collecting the methane, but we're also solving a lot of the environmental benefits. And it should be said that a small dairy farm produces about 6 times more methane than it can use. And that's what Bennamann does. We collect that excess, sell and share the profit. Why is that important for vehicles? Well, this year, for those who don't know, New Holland are releasing the methane tractor. It's going into serial production next year. Now, for those that don't know, because it has a -86-fold improvement over a zero carbon fuel, for a typical year's use, this tractor is equivalent to taking 680 cars on the road annually. So you can imagine the benefit of actually capturing this dirty gas from slurry, upgrading it, putting it into a vehicle like this that can do all the work on the farm. And this tractor does everything a diesel tractor can do. To give you an idea of the return for a farmer, a typical 150-head dairy farm produces around about 40 tonnes of fugitive methane. And so the farmer, once we processed it and sold it, that's worth between £10,000 and £15,000 in cash and operational savings. And that gives you an equivalent carbon footprint saving of 3,400 tonnes, which will take the farm off grid or make it negative carbon. What makes this all possible is the fact that as a liquid, methane takes up 1/600th of the volume. So normally natural gas, which is mostly methane, is transported through pipelines because it's a gas. But if you convert it to liquid, then it only takes up a much smaller volume. The problem is, as explained in this video, but as 1/600th of the volume, we can then transport it by road, which means that we've got no reliance on the electricity grid or the gas grid. And this little video explains how it works. should say as a liquid, methane's also got the same energy density or higher energy density as diesel. So it can replace, for heavy vehicles such as trucks, certainly over 3.5 ton, where there isn't really an electric vehicle equivalent, it can replace diesel vehicles and any trucks that are bigger, and obviously tractors. So where are we different? Well, we don't do AD is ultimately it. Certainly at this moment in time, all we're doing is capturing dirty gas from slurry lagoons by fitting a cover. But that also does a number of interesting things for the farmer. It reduces the amount of water that gets into the slurries. They don't have to spread as much. It also solves all the problem with smells, and also there's a big safety issues. And in 2025, farms are going to have to cover their lagoons anyway, but there's no plan at the moment for them to use the ammonia or the methane that comes off. And if you compare this to large scale AD, where they're actually generating gas through growing energy crops or using food waste, we don't have any operational costs. We just have a great big hole in the ground with a storage bag placed on top. And we have a saying in Bennamann that the bigger the bag, the better, i.e. the more slurry we can keep in it, the costs go down in terms of the amount of gas it produces. And there's virtually no running costs as far as the farmer is concerned. In fact, it's running savings. So this year, we're going to put the whole thing together. Over the last 10 years, we've slowly been building all of the different bits of the infrastructure required to take dirty biogas from a lagoon and convert it into vehicle fuel. Now, we've been working with Cornwall Council and Cormac on this for over 3 years. First of all, converting their hot boxes and running it off gas from the farm. And now more recently, Cormac have taken their first methane truck, and there's 3 more on order for the 6-farm pilot. Now, the reason we've got 6 farms there is because the innovative thing that Bennamann does is that we actually move the gas processing plant to the farm. So all that happens at the farm is the slurry gets treated as normal, goes into a lagoon, gas is stored, about a week's worth of gas is stored over the lagoon. And then once a week, when the gas bag is full, truck turns up, processes it, converts it into compressed or liquid methane, depending on what the customer wants, and delivers it to the customer. On the bottom right hand there is Cormac's first methane truck, and that's been running since November. 6 other farms in the pilot. The first one at the bottom is Trenance, that's coming online in July. The next 2, the order's been placed, so we'll be starting those in the next couple of weeks. And then we have 3 more next year. But interesting to note that Cornwall Council has 58 tenant dairy farms, and the gas from those farms will power their entire 1,100 vehicle fleet. So from 58 farms over the next 5 years, if the plan goes according to plan, will mean that Cormac are running a massively carbon negative fleet of vehicles. But you don't just get fugitive emissions from slurry, you also get fugitive emissions from grass waste. So anywhere where you see grass waste piled up on the side of the road, or other waste, chippings from tree cuttings, etc., leaves, you'll get methane, NOx, ammonia, and carbon dioxide, and hydrogen actually is not on there, and heat. And so we can actually now consider the grassland management of golf courses, sports facilities, and this is where the energy hub starts to come in. What's really important is here, though, is that we're now going to start producing biomethane. Whilst there will be methane coming off big piles of grass, we're going to actually collect it all, we're going to process it, and we're going to start to process and produce a lot more methane. Now, when we do that, we've got to be really careful to make sure that none of that gets into the atmosphere, because in the same way capturing fugitive methane gives you an 86-fold advantage, if you make methane that wouldn't otherwise occur in nature and lose 2 to 3%, you've now got to multiply that by 86. And so 2% loss from an anaerobic digester is worse than burning coal from a climate change point of view. And I'll talk a little bit more about that in a minute. Fortunately, the tools are in place that allow us to actually find those leaks. Now, target markets for the excess fugitive methane from this kind of market, we're now starting to produce a lot more energy. What you've got to remember is cows take 5/6 of the energy from the grass out. When we deal with grass, it's got 6 times more energy than a slurry lagoon. So we produce a lot more methane a lot more quickly. But typically, we're looking at large vehicle fleets where there is no electric or hydrogen equivalent yet. So we can immediately turn over, and companies like Waitrose have already decided they're converting their fleets over to compressed and liquid methane. And we're talking to them about using liquid fugitive methane as we are with other supermarkets. So it gives you a massive 10-fold reduction in the carbon footprint of their fleet. So where we see fugitive methane being used and really good quality biomethane where none has been lost is in heavy vehicles and also high power energy demanding applications where we don't have a solution for things like hydrogen because they just cannot get the storage from the gas. Now, another really interesting market for us is actually in terms of charging electric vehicles. So we're now using, if you look at the graph on the right, shows the carbon footprint of a diesel Golf versus an e-Golf. And what you see is the blue line is actually the e-Golf. It starts off leaving the factory with 0 miles with a carbon footprint of 11 tons, whereas the diesel Golf has actually only got 6 tons. And the electric Golf is only better using grid electricity after 115,000 miles. It will never recover its carbon footprint. Now, if you go to using fugitive methane to generate the electricity, you only need to charge the vehicle 20 times or do 6,000 kilometers, and the vehicle's lost its carbon footprint. So again, high power applications where you can use fugitive methane in a negative carbon footprint will actually reduce the carbon footprint of energy intense products such as electric vehicles and diesel vehicles. So if we now start to look at biomethane potential from sustainable grassland, which I spoke a little bit about in the last talk, and I'm not sure how long I've got, but what we've been doing is trying to work out, we don't want to have fields of monocultured grass, and we don't want to see fields of bare grass. We want crops that are biodiverse, have a variety of species which sustain wildlife. And what we've been doing at Bennamann at our site at China is we've actually been carrying out experiments on, in this instance, 2 types of grass. One is your rye, Italian rye, which is a sort of like the industrial product used in agriculture, heavily reliant on fertilizers, and alternatively herbal ley. Now, herbal ley has got a variety of grasses. It's also got your clovers, which are nitrogen sustaining. It's got things like chicory and docks, which are deep rooted, which break up carbon, break up compaction. And so if you look at the bottom right, what you'll see is these are the sort of methane potential yields from a biodiverse herbal ley in the solid blue, and your industrial standard as it is at the moment, your ryegrass. And what you actually see is in all instances, apart from one where it's close, the herbal ley dramatically outperforms your industrial ryegrass. Now, what we've been also doing is comparing the way that we manage the grass. And so by changing the rate at which we cut it, we've been looking at variability. And what we found is depending on the way we cut the grass, we can increase the methane potential by nearly 200%. And we're now in a position where we've been working these numbers out from comparing the dry matter and then in further methane. And this year, at the bottom left, you can see we have a full-blown biolab where we'll be actually taking those samples, converting into methane and getting real numbers. And this takes us on. So imagine now Bennamann has got this global network of grass-powered anaerobic digesters with local people going out, cutting the grass, servicing the digesters, sports fields, grasslands, golf courses, marginal land from farms where the crop yield isn't particularly good, but they can grow, a very biodiverse meadow grass and then create a fuel for their tractor, take the farm off grid. But that global network, how do you determine when you send out the person to cut the grass or manage it? What you really need is you need to know how long that grass is every day, so you can instruct your workforce to go out and give them an app which tells them which farm, which customer they're going out to next, which piece of equipment needs servicing. So for those who don't know, we're actually span out of the European Space Agency. Part of the technology we use in the cryogenic system was developed, ironically, for looking at climate change. We use a particular type of cryogen cooler. And we've been working with the UK Space Agency, ESA, and the Application Centre at Harwell to build up a business model for a space-enabled energy network. So we use existing satellite technology to measure the height of the grass in every 10-metre patch of the planet on a daily basis. Right? And we've shown this year that it works. So we can actually look at the global estate of grass, any country where it's growing, and other vegetation as well. We can actually infer the soil quality in terms of moisture as well. So this was the question we asked last year this time. Can we use freely available satellite imagery to assess the methane potential of grassland areas? So this is common. You can see there's a lot of grass, right? We get a temporal resolution of about 5 days, depending on cloud cover. So that's a 10-metre pixel. We generally get a clear shot one in every 5 days, but bear in mind, grass takes 2 weeks, 3 weeks before we have to cut it. So generally, we get a pretty good image. And we've also got data going back to 2015 to the present day. So we can actually go back and look at all of that history and infer what the grass potential is of that land and actually how much it could be improved. We have 10 bands of imagery. This is the plot, an aerial plot from the drone on the bottom left. And then there's the Sentinel-2 image in the middle, showing the farm, and you can see the different plots. And then by looking at the false color images, we can infer roughly 2 days growth between the plots. So we were actually confirmed this year that we were able to track and predict grass yield. So now imagine this, that basically you're going to get up to 10,000 litres of petrol per hectare of marginal land. You're going to get that everywhere on the planet. if you want it and if it's available. And you can actually manage that whole estate using existing satellite technology. So this is Bennamann's bigger vision. This is where we're heading once we sorted out the fugitive methane issue. This just shows you what happens. So this is actually a grass digestion. And this is over a period of 2 weeks, roughly, just slightly more than 2 weeks. But the really interesting thing here is that these are the bugs. So these are 4 experiments. And what we've done is we've given them different mixes of grass, prepared in different ways or just raw grass. And each time you see a bump on the curve, we fed it. So that little dot, if I can place my mouse over it, wherever there's a vertical line, I'm sorry, I can't do that. Wherever you see a little vertical line, that's a little feed of solution grass that's got in. And then you'll see that rapid increase in gas production, and then it will stagnate. And basically, they just eat up all the available energy and stop. And what we've shown is that this is a completely sustainable process. And we're using the existing natural bugs on the grass. We're not having to create any fancy bacteria. Now, as I said earlier, if we're going to start producing biomethane rather than capture fugitive methane, we need to audit that estate. We need to ensure that it's taken from sustainably managed marginal grasslands. We're not in the business of replacing food agriculture, but it has the potential to produce a significant proportion of the UK's energy. So we're looking at roadside verges, not wetlands, but areas where they have poor yield in the lower parts of farms, higher parts of farms to produce sustainable lays. Because it has a much higher energy density than diesel, it provides a solution for heavy vehicles such as tractors, and also instantaneous high power energy generation for electric vehicle chargers. But it's a powerful greenhouse gas, so any production operations must ensure there is zero unwanted release. And that includes the tailpipe emissions of the vehicle, so we can't have any methane slip through the engine. If you lose something like 0.2% of the methane, then you've pretty much eradicated the benefit of a biomethane solution. But fortunately, the technology now exists to remotely track and detect methane. And we're working with 2 companies, and just to give you an idea,